To understand Kalm skip, we must first understand some of how the world map works. When you're in the world map, the game can't load the entire map in memory at the same time. It only loads the parts of the world map that you are close enough to be able to see. More specifically, the world map is divided into many small regions, and up to 32 of these regions are loaded at a time. When you get sufficiently far away from a region, it'll be overwritten in memory with a new region being loaded in somewhere else. Here's a visualization of the world map regions that are currently being loaded as I move around, courtesy of Mav. The data for these world map regions are stored in the world map mesh heap. This is an array with 32 slots, each 4,608 bytes large, where each slot has all of the data for the triangle mesh for a world map region. In each of these blocks of data are two main sections. First, triangle data, then vertex data. The world map mesh is made up of a lot of triangles. A triangle can be defined by its 3 vertices, and that's exactly what this game does. However, the game doesn't directly define the coordinates of each of the vertices of a triangle within the triangle itself. Instead, it has indices into another list of vertices that tell the game which vertex each of its 3 vertices are. In essence, instead of a triangle defining where each of its 3 vertices are, it defines which vertices it's using from another list of vertices. The list of vertices is specific to each world map region, and it's stored after the region's triangle data in its segment of the world map mesh heap. When the game wants to tell what triangle Cloud is on, it first determines what world map region Cloud is in based on his coordinates. Then the game only considers the triangles within that region's triangle data. It iterates through all of that region's triangles until it finds one that Cloud is standing on. If such a triangle is found, then Cloud is made to stand on top of it. However, the game also has Cloud remember this triangle by adding it to the front of a list of triangles he has. More specifically, the game stores within Cloud a pointer to this triangle's data in the mesh heap, in addition to the X and Z world map region coordinates this triangle is in. Every world map object has room to store up to 6 of these triangles. In fact, I skipped a step before. When the game is looking for a triangle for Cloud to stand on, it first looks at his stored triangles. If a stored triangle's world map region is the same as the one Cloud is in, then the game will check if Cloud can stand on this triangle, and if the game thinks he can, then it skips everything else and just puts him on that triangle. It's also important to note that if Cloud bumps into a triangle that he cannot walk on, such as a mountain, then he has not moved onto that triangle, but this interaction is enough to add this triangle to Cloud's stored triangles. Now here's an important detail. The game does not clear or change Cloud's stored triangle pointers when he gets on, rides, or gets off a Chocobo. That means that if you get on a Chocobo over here, then move somewhere else, the game may still attempt to use whatever data Cloud's triangle pointers point to as triangle data to test if Cloud should stand on it or not. This data, however, could have changed since this pointer was made, since the region of the world map this triangle pointer was originally pointed to could have unloaded and been overwritten with data for a new region. This floor triangle is in region 2116. When I stand on it, a new entry is added to Cloud's stored triangle pointers, which refers to this triangle within region 2116. That region is currently loaded in slot 30 in the world map mesh heap, so the pointer is pointing somewhere within slot 30. Observe on this visualizer that when I move far enough away, region 2116 is unloaded and slot 30 takes on the data of a new region. However, the pointer within Cloud's stored triangles hasn't changed or been erased. It's still the same as it was before, but now it's pointing to whatever data loaded in its place. Now note that if I get off the Chocobo right now and walk around, nothing interesting is going to happen. That's because I'm not within the region the stale triangle pointer is assigned to. Recall that, when Cloud stores a triangle, he stores both a pointer to the triangle and the world map region coordinates the triangle is in. If Cloud isn't in that world map region, the game does not even make an attempt to put Cloud on that triangle. But what if we were to go back to region 2116 before dismounting the Chocobo? When I return, you'll see that region 2116 isn't loaded in slot 30, it's loaded in slot 20 instead. However, Cloud still has a stored triangle within region 2116 whose data is located within slot 30. When Cloud gets off the Chocobo, the game wants to put him on a triangle, and so it starts the procedure by checking his stored triangles. It finds this triangle within region 2116, and so it follows the corresponding pointer and uses it to check if Cloud should be standing on the triangle that's based on the data located at that pointer. If we look at the data located there, we can see the first 3 bytes, which define the vertex indices this triangle uses, are 0, 0, and 0. Well, clearly this isn't a normal triangle. In fact, we're not even looking at triangle data at all. We're actually looking inside another region's vertex list and treating whatever we find there as data for a triangle that's within region 2116. The game obviously thinks we can stand on this messed up triangle, as it seems to completely ignore all the other triangles in this region, and just puts us at the height of the ocean. We can walk freely out here up to a point at which we get stuck. You'll see that we get stopped at the edges of this region, which makes sense as the game only thinks this glitched triangle is within region 2116, so when we attempt to pass to another region, the game does not consider this as a triangle we could be standing on, and so it does not attempt to determine if we are on it. The exception is if we move north here, because in this case, the game sees us moving from one valid triangle to another valid triangle. Now if you've been paying attention, you should have one big question. Why are we able to walk a significant distance on this triangle if it's using vertices 0, 0, and 0? Meaning all its 3 vertices should be at the same point. Shouldn't this triangle have 0 area, and so you shouldn't be able to move on it at all? We'll refer to a triangle whose 3 vertices are at the same coordinates as a point triangle, since the entire triangle is contained within a single point. It turns out the function that determines if a player is on a given triangle does not properly handle the case of a point triangle. If the game tries to determine if the player is on a point triangle, it always returns the player is on that triangle regardless of their coordinates. To understand why this is the case, we're going to have to look at some code. Here's a decompilation of this function in the original game code, however, I've rewritten a simplified version of the relevant sections in Python. This should be easier to understand. Here's a function where the triangle is checked against the player's position. The vertices of the triangle being checked are the parameters a, b, and c, and the player's position is pause. This section of code consists of 3 checks, and if any of them fail, the player is determined to not be standing on the triangle, otherwise they are standing on the triangle. We'll be looking at the case where we're given a point triangle, or a triangle where a equals b equals c. Notice that in all of these checks, the vector I is created based on the difference in the x and z coordinates in a, b, or c. However, since a equals b equals c, the difference between the x or z coordinates between any 2 of these points is always 0, so i's x and z coordinates will always be 0. These points are just multiplied by the coordinates of j, but anything times 0 is always 0, so this condition just becomes 0 minus 0, which is 0. 0 is not greater than 0, so this condition is never met, and the function doesn't return false when it probably should. The same thing happens for all 3 of these conditions, and beyond that, the function will always return true. Since the player's coordinates are always multiplied by 0, they don't matter, and so the function returns true, and the game says the player is on the triangle no matter where they actually are. You've probably noticed that after bumping against the edge of this glitched triangle a few times, you get stuck and can no longer move. This happens because bumping triangles you cannot move into also adds those triangles to Cloud's stored triangles list. In this case, Cloud is bumping into the triangles that make up the water surface, and since Cloud can't stand on water, he isn't allowed to move onto them. Cloud can only remember 6 triangles, and in order to keep standing on this glitched ground, the stale triangle reference must be one of them. However, as you're bumping into triangles, you keep adding them to Cloud's list of stored triangles. Older triangles will eventually be pushed off the end of this list and forgotten about, and after bumping into enough triangles, this will happen to the stale reference that lets us be out of bounds in the first place. The game now fails to see Cloud as being on a valid triangle, and so he cannot move. Let's now see all of this in action with the standard Kalm skip setup. As you can see, if we were to get a glitched triangle in this region, region 2116, we won't be able to reach the Junon side of the river. However, if we were to go one region to the right, region 2216, then there's an accessible triangle on the Junon side of the river right here that we could cross to. We get off the Chocobo, then bump into this wall in region 2216 which adds it to Cloud's stored triangles. Then we get back on the Chocobo and start our movement to unload these regions of the world map. Region 2216 was loaded in slot 25, and here you see that slot unloading and being replaced by a new region loaded elsewhere. When we get back to the starting area, you can see that slot 28 holds the data for this world map region instead, but we still have our original triangle pointer just like before in slot 25. We get off the Chocobo and walk into the mountain, and since we're moving into region 2216, the game will check the stored triangle pointer we originally set up in that region. The mesh data got swapped out from underneath the stored triangle pointer, so now the data at that location creates a point triangle, so Cloud can stand within this region and make his way over to Junon.